Hello everyone, today we are looking at equating redox reactions using the electron-ion balance method. The medium in which we are considering these reactions will be alkaline. Given the chemical reaction of zinc plus sodium by 3 in the presence of sodium H, this is the alkaline environment. We get sodium 2 zinc 2, zinc from sodium, ammonia and water. Recall that the electron-ion balance method is broken down into steps. Step 1. We need to make an equation in ionic molecular form for a given chemical reaction that has not been equated. To do this, we take into account which substances are strong electrolytes. Hence, we show that they decompose into ions, and we do not write down the ions that will be reduced. Zinc is a simple substance, sodium, but 3 is a strong electrolyte, will decompose into sodium plus and sodium minus. Sodium H is also a strong electrolyte, will decompose into sodium plus and H minus. Sodium salts are all soluble, so sodium 2 and zinc 2 will also decompose into sodium and charge plus and zinc and charge 2 minus. Ammonia is a gas that does not dissociate water, is a weak electrolyte. Thus we have the equation in molecular ionic form. The next step is we need to determine which particles have changed charges or shape. That would be zinc, changing to zinc O2 charge 2 minus, and it will be a NO3 particle changing to ammonia. Let's make up the half reactions. The first half reaction would be for zinc. Zinc converts to zinc. O2 with a charge of 2 minus. The second half reaction is for KO3. But 3 goes to but 3. The next step is for us to determine how each of the half reactions requires the addition of either water or the calculation of alkali ions O3. In the first reaction, we need to add oxygen. In an alkaline environment, this is done by adding O3 ions. Then we will have water on the right side. To equalize the number of OH groups, we will put a factor of 2 for OH in front of the OH formula, considering that we need to add 2 oxygen. And then we'll have a coefficient of 2 to water. In the second half reaction, we need to remove the oxygen, and therefore this is done by adding water. And on the right hand side will be the ionic OH. To equilibrate here, we need to put a factor of 6 in front of the water formula and a factor of 9 in front of the OH formula. Let's check. Nitrogen 1, 1. Hydrogen 12, and here 12, oxygen 9, and on the right side 9. Next step, we need to determine what number of electrons will be involved. In the first reaction, we have minus 4 charges, on the right minus 2. Degree of oxidation, the particle charge increases, therefore this particle will give up 2 electrons. Let's write them down on the right side. In the second half reaction, we have a minus charge on the left side and 9 minus on the right side. Hence, there is a decrease in charge, a decrease in oxidation degree. Hence, we add 8 electrons to the left side. The next step, we need to take the number of electrons we've found, 2, 8. So we swap them crosswise, 8, 2, and as they're reduced, we get 4 and 1. Next, we indicate what the zinc is in this reaction. It's giving up electrons, so it's an oxidizing agent. And it's a reducing agent. The second process is reduction. And the ion is the oxidizer. We're going to do a final molecular ionic equation with these multipliers. For zinc plus 4 by 416 OH charge minus. From the first half reaction, we chose our particles dom naught by 4. In the second equation, the multipliers are 1, hence no 3 minus, plus 6H2, or the number of electrons involved, in which case we have 8 electrons. Then we go to the right hand side. Here we have 4 zinc O 2 minus plus plus 8 H2O plus the second half reaction NH3 and plus 9 OH minus, and the number of electrons that will be given up plus 8 electrons. The number of electrons is balanced. Now we look to see if there are similar ones. The OH ions are similar, and let's underline them and look on the left hand side. We've got 16 OHs. On the right hand side we've got 9. Then where there are less we remove, and here we leave the difference. That will be 7. We have similar to that. And water on the left side is 6. On the right side is 8. Where there's less, we take away and leave the difference here. There are no more similar ones. The electrons that are involved here are the same on the left and on the right. Now we put the coefficients we found into our original molecular equation. 4 in front of the zinc, in front of OH ions, so in front of OH sodium, the coefficient is 7. In front of the No3, we don't need a 1, we don't write it down. In front of the zinc, O24. So in front of the sodium, 2 zinc O24, 2 for water, ammonia 1. Now we need to check. On the left side did not participate in the process sodium. On the left side of sodium 8, on the right side 8. And as usual we check on oxygen. On the left side 3 plus 7, 10. On the right side 4 by 2, 8 plus 2, we get 10. Our equation is equated. Here I would like to draw your attention to the fact that in an acidic environment and in an alkaline environment, water acts differently. In an acidic environment, water adds oxygen, but in an alkaline environment, water has a different function in this process. It removes oxygen from these ionic forms, from these ions or molecules. That's all for today. Goodbye.